Okay, we'll talk about homework 4, part 3, the pizza making example. First, we're going to have a server version using different server. You can see I'm not going to show every detail how to build this model. By now, you probably already know enough to look at the layout, knowing what's going on. And of course, we have 4 resources on the down here, um, and the order generator from the source, entity order generator from the source, based on a time varied arrival rate table, and then the order goes to a combiner. Separator. The separator actually is the server called taking the order and have a certain processing time. And also, before we process the order, we need to seize the worker. And after we done with processing, we need to release the order and also assigning, make a copy of the current order to number of pizza. Okay, so the pizza going this way, which is the member nodes coming out this way, and based on number of pizza in that order and generate, and then you have a server to make pizza. Okay, and you have a server to bake the pizza in the oven, and the oven has a capacity of 8, and also box the pizza with a capacity of 3 on the table, but you also need to seize and release the worker based on the same thing of making pizza. Only things you don't need staff member is baking the pizza, so that part we don't need any uh, second door resource. We only need the oven space, which is 8 of them. Okay, after that, the customer come in and using a time path, come back to pick up their order between 10 to 40 minutes. Then we get this combiner. This combiner match the member and the parents based on the order ID. Okay, model entity order ID. And so based on number of pizza we have, and also during this cashier process, we need to seize and release order. So the trick is you need to set up a model level state variable for order ID, and each time you generate a new order, and basically you increase the order ID by 1 and copy number of pizza in that order into uh, model entity number of pizza, which is within that order how many pizza we have. Later on, we use this to create a pizza entity. Okay, we refer to a table pizza process, and this is the data section. We have 1 pizza, 2 pizza, 3 pizza, 4 pizza in each order, and their probability based on that. So this, I'm just going to very quickly describe this part 3 because they are very much the same as we've done it before. You have a separator to separate a TV to electronic and screen, and then you process each part separately. The only thing is now you have 1 order which generate number of pizza, which is based on the order type, okay, quantity. So this part is fairly straightforward. This is one set of implementation. And if you look at the part 4, you're adding a part-time portion. You're adding a part-time, actually you're adding a resource with a schedule, with a part-time, based on 4 to 8 p.m. you have certain number of part-time. So here we have set up a property, number of phone line, part-time capacity, and profit for each piece. So we can using a part-time schedule um, based on the work schedule, giving a part-time schedule, okay, between 4 to 8 p.m. on what type of capacity we have, okay. And the parking capacity is basically a property defined in the property section, part-time capacity. So very easy, we can convert part 3 to part 4. But here in the part 4, I have a slightly different implementation to show you we can done it differently. We're using a server instead of a separator, and the server processes the order, but we have an add-on process, and after it get processed, we actually come here to create a number of pieces right here and transfer them to the piece or transfer node, which is this node, and then process the piece. It basically is the same thing, but however, and this part is the part you can decide which implementation you will prefer to use. Uh, so there are two different type of implementation. And I'm going to run this, so you see, and the order coming down this way, and with order number, and then the pieces going up that way based on number of pieces they created, and they combine in this place, based on the number of pieces. So the quantity of combining is different for each one of the order, and they match their order ID they send on. This represents number of order. We have 168 for the 10-hour period, and this is 280 pieces sold during that period of time. So this part we have the processing stop after 11 hours, so you can see how fast the process is. Around 10:30, 10:20, depends on how you set up the number of phone lines and number of part-time worker. Also, part 4 are using a slightly different implementation than part 3. Let's see, part 3. Part 3 are using a diverting node. So here we're changing if the input buffer content of the order taking process is equals to number of phone line we have, then we reject. For part 4, I'm using the transfer in constraint, on the server. So I have set up a customized transfer in constraint and using the similar condition if the, if the input buffer content number of waiting is less than number of phone line, then we're allowed to go in, otherwise we reject it, and actually that's it. So showing you several different variation to implement the same thing, and you can decide which one to choose to implement. Basically all these different implementation we talk about in the class. Also, you exercised in other previous homeworks assignment before. So I'm not going to go into detail, and these type of things I'm going to leave as exercise for you to accomplish, but to show you it is possible to do it that way. And also, in this part, I'm going to show a third implementation using part sequences Okay, so here I'm going to see, uh, as we described in chapter 15, starting from 15.5 to 15.8, we describe various methods using a task sequence to implement this. Uh, we can actually largely simplify the process. And what we do is I'm going to show you first. And in this case, we only need one process called order processing. We're adding all the resource constraint as external resources. And within this server, we instead of using a specific time, we specify task sequences, and then we have 6 text sequences described in this entire homework assignment. So I'm going to describe each detail of the task sequence using a PowerPoint. Let's take a look real quick. I'm going to briefly discuss that. And look at this PowerPoint sequence. And the process is actually start from taking an order. Once it takes an order, and separate into 2 separate parallel process. One we call it 20.1, the other one we call it 20.2 after 10. So 20.1, 20.2 execute right after 10, and 20.1 is making pizza, is using a add-on process to do so. The 20.2 is customer return. Basically, customer take a walk, come back in between 10 to 40 minutes. These two are parallel. And 20.1 followed by 30.1 is baking the pizza using triangular distribution between 6 to 10 minutes. And after that, pizza was baked, and the pizzas are baked, and then followed by 40.1. So you see the 20.1 followed by 30.1, and 30.1 followed by 40.1. And 40.1 is basically boxing the pizza, and you also here I implement using another add-on process. And for the baking process, we don't need to using an add-on process. We can directly just specify a time. And when the 40.1 is finished and the 20.2 both finished, then we can execute the 50. 50 is basically the cashier. I'm sorry, forgot to do this one. It's a cashier process to check out, and then both of them check out with uniform distribute the processing checkout time of 1.5 minutes or 2.5 minutes. So this is a fairly straightforward. You have 2 parallel process tasks going on. One is making pizza until the box the pizza, and the other one is the customer go for a walk. So let's look at how we're going to implement this in that regard. And showing you these 2 add-on process. One is making pizza. Of course, you seize the table because the table only have 3 spaces. So I'm using external entity. Let's see. We're using the pizza making table has a capacity of 3. Box folding table also has a capacity of 3. The resources for the oven, we have a capacity of 8 in that case. So we seize the table first, and we seize the staff member. Then we delay for a period of time to making the pizza for the staff, specific staff on that table, and then release both. However, the boxing portion is also the same. We can seize the staff, folding the boxes for determining how many of them, and release the staff afterwards. But here we have a little bit different implementation than the using server. In this implementation, we don't generate additional pizza as individual pizza, or we process them together. The concept is basically uh, if I'm making a pizza, I'm going to making the pizza within the same order using the same staff member. I'm not going to using different staff member to making multiple pizza within a single order. And also the same thing for the boxing portion. If I'm boxing the pizza, I'm boxing them for the same order using the same staff. So how I'm going to do this? So let's take a look. Click on this order processing. Since we're using sequence, there's no capacity on this dummy server. It just represents a server place. We're going to carry out 6 different tasks. Okay, the 6 different tasks, like I said, 10 is taking the order. Taking order takes a specific amount of time, and also we need a staff member and randomly choose from the employee list. After that, I'm going to bring up the presentation again. I'm going to go to the making pizza and send on to the customer return. There's 20.1 and 20.2. So 20.1 is making pizza using this process, okay? Making pizza process. I'm not going to do any staff member here since we need to seize both the table and the staff member within that process. Okay, and then 20.2 is just simply a delay processing time as uniformly distributed between 10 to 40 minutes. Okay, and after 20.1 is finished, then we go on to 30.1 and is baking the pizza. And I'm going to grab the oven based on number of pizza in that particular order. So I'm going to grab however many oven space from depends on the number of pizza in that order. And also after that I'm going to 30.1 is done. We're going to execute 40.1, which is folding boxes and boxing the pizza. I'm using a box folding process. However, before I go into running that add-on process, I grab the box folding table over here as a resource requirement. So therefore, within that, we don't have any need to grab table for folding pizza. Okay, so the only thing that we want to talk about is since we process the entire order as one entity, so the processing time will be multiplied by number of pizza in that order. Same thing for the order processing here as well. So these are the uh, processing time we talking about dealing with multiple pizza in that process. And finally, we go in, we see the last portions, cashier. Cashiers and selecting from a set of a resource from the employee randomly, and processing time is 1 to 3 minutes or 1.5 to 2.5 minutes. So these are the things actually we're using a series of a task sequence within one single server to accomplish that. Um, you can choose this implementation as well. Uh, okay, you can choose this implementation as well as an alternative. And actually, the outcome of the simulation are very similar. And slightly different concept for this implementation is task force. Since this is a new topic with introduced in chapter 15, the second half of a chapter 15. So I want you to take an exercise because later on we can do you're going to need to use this in your other assignment as well. So make sure you have some exposure on exercise on these type of concept as well. So this will conclude the brief discussion on part 3 and part 4. We probably should have a short video on part 5 in that case, since it's a little bit tricky on how to determine efficiency on each one of the staff resources. So we'll talk about that later.